Qt6 and CPP class implementation, the constructor and destructor class. This video is going to talk about constructors and deconstructors. Why? Because we want to talk about the object lifecycle. This is not specific to Qt. This is a C++ thing, actually. Most programming languages have a concept of a constructor and a deconstructor. However, what we want to talk about is the object lifecycle from the perspective of Qt. And remember, we talked that QObject does not like to be copied. So we have to handle things a little bit carefully here. So let's go ahead and right-click, add new, and we're going to make a class. And now that we've done this one, I'm going to go through this a little bit faster. Each time I may even start videos with classes or any pre-made, we'll say a laptop. From here, what we want to do is take a base class, and remember, it's going to include QObject and add that macro. It's going to recommend some file names. We can change us if we want. I'm going to change this to uppercase, and notice it does not change the file name case. When hit next and finish, and no, I don't want it to copy it. I'm just going to say laptop, super easy for us to do. Now, somebody out there is going to say, well, CMake is incredibly powerful, and there are scripts and functionality out there where you can include all the files automatically. Why aren't you doing that? Because I want to show people how to add these. And also it does become a security concern. And I don't want to take that bad habit through somebody lessons into eventually their career, and then they get in trouble for doing that. That's actually one way that hackers will infiltrate a program, is they'll sneak a header file in there. And some would-be developer compiles it and doesn't realize it, and then the program is completely altered. So it gets way more in-depth than that. But you will not see me automatically include these things. All right, now that we've got our header and our source, let's go ahead and look at our laptop. Strikingly similar to the previous video because, well, it's very simple. We're including QObject. We're inheriting it. We've got that macro in our private section, and we have our constructor. Let's go ahead and add in. Don't really need it because it does it automatically, but just in case you need it to debug. So we've got our constructor, and I'm going to put a comment right here, and I want a deconstructor. This is when the object is destroyed. So when it's created and when it's destroyed, the syntax for this is a little bit, well, I'm going to say it's a little bit weird, but basically it's the tilde. And if you don't know what a tilde is, it's on the keyboard. Look over on your top left by the number 1. You're going to probably have to hit shift. And then that character, which looks like that, if you don't hit shift, that's the tilde or tilde, laptop. So you want the name, and then it's just a normal function. That's all there is to it, really. That's it. It's really not super hard. Now, you notice up here in the constructor is this QObject, a pointer to something called parent equals null pointer. That's different than saying 0. That's saying no point. I mean, it's just simply not there. It's never been set. I'm going to do a comma and a Q string name. So we're going to add in our own special little property. They're called name. Actually, it's a parameter. You see this light bulb appears. It says apply changes to definition. If I don't click this, that means that this here does not match this, and we'll get some sort of error. You see this out of line definition. That means it just simply does not match the declaration that's in the header file. Those two have to match. So when you see that little light bulb there, that's a super friendly way of doing it, but I can't get it to reappear. We got out, save it, and let's try that again. That's how light bulb's back. And if I click this light bulb, it will change it automatically for me. And then we get this other thing, missing default argument. Now, why are we getting that? This is super frustrating in C++ land, but whenever we have this equal sign, we're telling it what a default argument is going to be, meaning what is it going to be if we simply don't include the information when we call it? So a big leap of faith moment, we're just going to say equals and then some question marks. If you didn't want to mess around with that, you could simply move it before you could do it, like right here. Wow, misspelled name. That's portable. But I wanted to show how we would add that if you can't get that light bulb to appear. Very simple. You just grab this switch over to the source and then paste it in here, minus the defaults, meaning we're not going to say no pointer or anything like that. Super confusing, I know. But again, this is a course on Qt programming, and that's all C++. I did tell you I was going to give you just enough C++ to survive. Alright, so now that we have that, let's flip back into our header and we're going to implement this de-constructor. In case you missed it, I'm just going to mouse over select it, right? Click refactor and add definition in CPP. If for whatever reason you can't get that menu to pop up, you can very easily just type this out. I'm going to type it out just for demonstration. And then colon, because we are in the laptop scope, we want the tilde laptop because that's our de-constructor. And then it's just simply a function, very, very simple, the way that works. Now I'm going to add in some other things. So for example, notices are in the public section, so the entire outside world will see this. And I'm going to add some functions here as well, so you can tell the difference between a variable and a function, because the function will have these parameters, or I should say these parentheses, and they could have parameters in there. So for example, we could say parents, or do string name or whatever we wanted to do here. For right now, they're just going to have no parameters. However, because they're functions, we also have to implement these. So if we were to try to build this, let's see if it builds. It kind of surprised if it did. Yeah, no return statement. It actually built that, even though we don't have that test in there. Usually that throws an error message for me, but we can add it in super quick. Might demonstrate that in a little bit here. Now we've got our functions. And I'm going to say Qt and our name. Let's just differentiate this. That way you know what we're talking about here. I'm saying this name equals name. So what I'm doing here is I'm saying this current object set the name to this guy. So we have a variable called name and of course a property, variable called name, two different ones. And there's a copy happening under the hood here. So you notice how this is not a pointer and it is not the address of or a reference. It's a copy. So we're literally just going to say make this equal. That's super confusing, I know, but that's how that works in C++. You could, if you wanted to, simply omit this, and it is the same thing now. This is where it gets a little confused, and it says explicitly assigning the value of a variable, the type Q string, to itself, meaning it thinks you're trying to use this instead of this, and that's why we use the this keyword. Can we say this in the tutorial anymore? I really tried to script that better, but I often try to do my videos unscripted. I legit did try to script that part though, so we simply have our constructor now to simplify this, speed this up just a little bit. We've got our de-constructor, and then we have some functions here. So as kilo, we're going to say return. This stat waits, and again, you don't really need this part. You say wait and automatically knows that it's part of this current object when you multiply that by 0.3. Again, I'm cheating. I'm going out on Google on a different monitor. So 45359 2, and that one convert pounds into kilograms. And then test, I'm going to just grab this and we're going to play around just a little bit here. Say this test. And then I want to do the name. Just to demonstrate that we can call a function from our current object. So the real question people are going to ask is, should you do this as kilo? Or just as kilo? It really doesn't matter from compiler's perspective, because it's going to do virtually the same thing. Be brutally honest, I tend to omit the word this unless I need that actual object for some specific reason, like you see in these QML, those. So to quickly recap here, we've created a blueprint called laptop that's inherent in object, and it's got the object macro. We have a constructor, a de-constructor, and then we have some properties here for variables. And we have some functions. That is our blueprint. These are all in the public scope, meaning the outside world can see these. So let's go to the outside world. We're in main, going to include our laptop. Now that we have this, I want to make two functions. First function I want to do is I want to do a void test. And I want to work with a laptop, but of course we have to be very careful not to copy a laptop. So I'm going to say a laptop. And machine, so we're going to say address of machine, or we're going to pass it by reference, not by value. We want to avoid a copy at all costs because Qt will not allow it. and then say machine that test. Very cool. Now let's go ahead and make some laptops. And I'm doing this specifically in a function so we can see the life cycle here. So I must say the laptop. And the parent here is null pointer. So we don't have a parent to give it. If we wanted to, we could pass this QCore application as a parent, a little bit more advanced than where we are right now. Don't really need it. So I'm just going to say no PTR or no pointer. I mean, we don't want to set it. And then I'm going to say for the name. And then let's call this one yours now. Someone out there is going to say, well, isn't null pointer the same as 0? Not really specifically. It does get translated to it, but they are kind of two different things. And this was going to be your laptop. Now, I say kind of two different things in the harsh reality is pointing to a 0 in memory, just because I know somebody in the comments going to say, wait a minute, I found this out on the internet and it says, you're wrong. You're probably right. I probably am wrong in that statement. But we're going to use null pointer because that's a cute way of doing it. So when I say mine only weighs 3 pounds and yours weighs 5, now let's go in to see some say test and asked. Now there's a bit of magic going on here. We're doing this on the stack. We're talking about memory now. So we're letting C++ manage this memory for us. We've created this, or I should say C++ has created it for us on the stack. Remember, the stack is the region of memory that the compiler or your program will manage automatically because it's managed automatically. It's going to delete it when it's no longer needed. And I should wear that differently. The stack's not actually deleting it, C++ says, but will be deleted from this stat. And this happens automatically. And it's doing that because it's in the scope. That's how the stack typically functions, is once something goes out of scope here, talking about these laptops, they're no longer used, they're out of scope. It will automatically get removed from memory here. So let's go ahead. I'm going to do make laptop save and run. And sure enough, we have my laptop constructor, your laptop constructor. So these are both been constructed in memory. In case you're wondering where that is, it's right here. It's our constructor. Then we are testing them and getting them as the name and the kilo. And then we are destroying them, or I should say it's destroying it for us automatically. That is being called right here in our de-constructor. And remember, it's got this funny little symbol in front of it that's, the difference between a constructor and de-constructor. Both should have the same name as your actual class, but the de-constructor has this funny little tilde in front of it. Now, you notice this happened automatically, this deconstructive. We didn't have to do anything. That's the dangerous bit with automatic memory management, is we don't control this. It's just going to be wiped out. So you notice how right here we have this address of we're passing by reference. If I get rid of that, suddenly we get this implicitly deleted copy constructor, because what's happening is we're telling the computer, construct this right here, and then here it would be automatically deleted. And that's bad. We don't want to do that because we're still trying to work with these things. So that is why you'll see me working a lot with either the I reference or with pointers. And we're going to talk about pointers a lot more. So the major takeaway from this video is you can start making your blueprints rather complex. And each one of these objects that we construct from the blueprint has a constructor and a deconstructor, and we have a full object lifecycle, and C++ can manage that lifecycle for us. So we've got to be a little bit careful about how we pass these objects between functions, because C++ will try to manage that memory for us. Let's move to next chapter. Introduction to inheritance. Inheritance is, well, a complex topic, but to clarify, it's a class that gains the members of their base. Think of it this way. For example, let's say we have a base class called person. It's a very boring class. It doesn't have any air, color, skin tone, gender, age, or anything like that. It just represents a person. Using inheritance, we can create a number of different classes. For example, we can create a class called Mark in a class called Jane. They are two totally different classes, but at their base, they're both people. They both inherit the person class. This video is going to talk about class inheritance, and this is arguably one of the more challenging aspects of C++ to really wrap your head around. We're going to try and make it super simple. but I'm going to have to defer to my notes several times just because we are talking about a complex topic here. So for example, let's say we have a square, a humble little square sitting out in the world doing its own thing. And let's give this a nice green color here, and let's say we want to inherit that. But we want to change it slightly, so it's going to be kind of like this. That's called inheritance, and we've done this before where we have a QObject and we make our class which inherits the properties of QObject. It's a completely different class, but it still has all the properties baked into it. One of the challenges here is you can take this to some sort of extreme. So for example, you could do something like this. At this type and then have this type. And then have this one. They're all different. So we're going to give them different colors here, just represent they are different. And boy, I'm running out of colors here. So let's give this one red. Let's give this one a blue. Randomly grabbing colors here. Bear with me, and then let's give this one a pretty hot pink. Why not? So anyways, point being, we have a QObject. We've created some sort of diamond class using QObject. And now we have like a red diamond, a blue diamond, and a pink diamond. You can do this. And in C++, you can take it to an even further extreme, where you can say, you know what, now you want some sort of circle that inherits from this, but also you want to take this pink diamond and put it inside that, and then take this red diamond and put it inside there as well. Let me kind of just move these off to the side so you get kind of this monstrosity, and this is called multiple inheritance right here. I'm going to demonstrate how C++ can do multiple inheritance, but Qt does not like doing multiple inheritance. Qt likes a nice straight down word. It doesn't like doing this multiple inheritance. Now, in case you're wondering how to get around this, it's called interfaces, which is something we'll talk about in another video. But this video is talking about inheritance. So let's flip it and take a look. I've got just a very simple application. There's absolutely nothing in it, and we're going to make a humble little class here. Go ahead, add new. It's going to be our animal class. It's going to be a QObject next finish. No, I don't want to add that in automatically. That in save it and then magically appears. So in our animal class here, we're going to say, include your debug. And then we want to know what is the basic property of an animal. Well, it has to be alive. At least it should be alive if it's an animal. So we're not going to say it has to be alive, and I'm going to do it right here. Just because I don't want to put it in the implementation file, I'm just going to return true. Very simple, probably the easiest function you will ever write in the history of anything now in our implementation file. I want to observe, I'm just going to copy some things off the screen here. I want to observe this being constructed. No, I was just going to say QInfo. This constructed very, very simple, the way that works. So if I go out here, let's go ahead and include animal. There we go. We can just simply get rid of that guy using. So everyone, we've done this before. This is not rocket science. Now we have inheritance. We have created a class that is inheriting QObject. Qt did a lot of that heavy work for us. We're going to start doing this manually now to show you how we can really play around with this. So for example, I'm going to go here, right click, and now going to add a class. I'm just going to say a little faster. I'm going to make a mammal. I think mammal's actually 2 M's. This is also going to be a QObject saying, and next, and no, I don't want to add that automatically. Thank you very much, Qt creator. Now notice how mammal is a QObject. Well, I want mammal to inherit animal because mammal is an animal. So I'm going to say include. Let's go ahead and shoot QDegug real quick. Now we're faced with some fundamental problems here. We are further down on the inheritance chain. So for example, we've gone from object to animal to mammal. So we want to inherit this right here, this animal. We need to change this QObject to, you guessed it, animal. We're inheriting the public aspect of animals. So if we go in animal, this is what we're inheriting. The public aspect of that class. Not quite done yet. We need to switch in here, and he knows how it still says QObject. We need to do animals. So we're still going to inherit animal, and we're going to set those constructor parameters here. Now, mammal is slightly different than animal. It is an animal, but it's slightly different. We're to say bull. As backbone, I think all mammals have a backbone. That's one of the defining characteristics, I believe, not a biological expert. And that's just going to return true, very simple little function doing this right that I don't need to mess around with anything else. And I'm going to beg, borrow, and steal this and put this in the mammal constructor. Pretty simple, the way that works. So now we have a clear inheritance chain. I want to take this even just ridiculously further. Plus all this stuff, because it's getting kind of complex here. We're going to, and now I'm going to just kind of whip through these real quick. And then I'm going to make a cat. Again, we've done this. You can feel free to rewind. I'm just going to whip right through it. There's no sense of wasting a lot of time. Also kind of demonstrating just how fast you can do development. I'm not even going at full speed. I'm still kind of slowing things down just because I'm trying to demonstrate this, and we're going to grab this mammal stuff here. It flipped right in a canine. I'm just going to be doing a bit of copy and pasting. Actually, I don't want animal, I want mammal. Assuming I got that correctly, if I did all right, so what I'm doing now is I'm seeing the canine is a mammal, which means it is also an animal that's called an inheritance chain. So let's switch here. If you get this type of issue here, really, that's just the compiler trying to catch up, figure out what I'm doing. So sometimes you'll get typing a little faster and you'll see these random errors pop up. And then as you type or save, you'll see them magically disappear. That's exactly what's going on. The only time you should really be afraid is if you do something like this and it doesn't go away. So I've got two errors on the screen. Initialize or mammal does not name blah, blah, blah. What that's really saying here is it has no idea what mammal is and why we're trying to inherit it, and then calling info with incomplete return type QDebug. That means we're missing and include C incomplete return type QDebug means there's no idea what we're doing here. So let's go out and fix both of those now. We go into feline, we're going to inherit mammal correctly. And we've included shutterbugs, so should I flip into feline, clear both those out at magic? All right, so let's close a bunch of this stuff, Saval. All right, so we've got our canine, and I'm going to add in a function mark. And I'm going to do this all on one line just to show that we can do it. I usually don't do it this way, and we can add another one-liner into our feline. All right, so cast in the meow really loud when they're angry, lip over some notes here just to demonstrate what we're doing now that we've got these classes flush out. And I realized that was the whole metric ton of copy and pasting. Forgive me, I'm going to delete this, include it. We're going to feline. And we're going to include the dog or the canine. Now we're going to create two of those. So I'm going to say, and feline. So there's a couple of things happening here under the hood and what's really going to demonstrate it when we run it. But I want to talk about really quick. We're saying canine, so we're saying C++. We have a data type called canine. It's going to open up our H file and say, okay, canine is a mammal. So it's going to open up mammal and say, okay, has all this, but it's also an animal. It's an open up that and say animal is also a QObject. It's going to start from the top and it's going to add all of the properties and methods and functions and variables and all that goodness from QObject and then from animal, then from mammal, then from canine. It's going to construct this object in the background. So it's going to do the same thing for feline. And I'm going to just comment on the cat just so we can see just the dog. Let's go ahead and run this. Notice that took slightly longer to build. And sure enough, animal, mammal, canines. So we're actually constructing three things, even though we're just creating a dog. That's the inheritance chain at work. You don't secure object because I don't have direct access to the QObject source code to put that Q info in there, but it's happening right above this animal. So it's creating QObject, animal, mammal, canine is going right down that whole inheritance chain. Now, because this is a dog, we can do things like this. Notice how we have all of these beautiful things. This is all of that in here and it's smashed into one. And we even have these deconstructors. We have a QObject deconstructor mammal, an animal, and a canine. And then we have all of this stuff so we can bark, for example. And that is coming if we mouse over here from canine bark and it's canine. And if I do a Q info, actually I don't need this right here and it's causing an error. As backbone, notice how it's saying mammal has backbone. It's smart enough to know where we're inheriting that from. And then Q info. Dog dot is alive, and sure enough, animal is alive, and we can do things like set object name, which is coming from QObjects. So there's the inheritance chain at work here. Now I want to and show you what's going on when we construct both the dog and cat. You see, there's a whole lot of construction going on here. It starts with the dog and it builds that up, and then it starts with the cat and it does the same thing. So point here is it starting at the top end, building this object in memory with all of its parents and base classes and things of that nature. Very complex little dance. It does all of it for us. Now, what I'm going to introduce here is, well, something I really dread doing. But someone out there is going to say, but can't C++ do what's called multiple inheritance? Couldn't you make some like hybrid monster of a dog and a cat combined? Why would you want to do this in some weird mad scientist? I don't know, but let's demonstrate. No, it cannot, or I should say should not work. So I'm going to say monster. And we're just going to do a QObject as a base class next. No, I don't want to do that on automatically. Let's jump into our semi-gloss. Some are already there when I say monster. In monster, let's add those files in. We've got a little bit of an issue ahead of us. Monster is going to be a conglomerate of pretty much all of these. So I need to include canine. Let's go ahead, try to include the bug here. Now, our first hurdle is we want to inherit QObject, but we also want to inherit feline and canine. Notice how they're just kind of separate. It's all in the public scope. We have our beautiful little constructor, and I'm not going to add a whole lot here. Let's go ahead and switch into the source. Now we have our constructor here. Want to say feline, we need to give it a parent. And that could be a null pointer, basically just giving it the same parent. So that's going up through the stack. Let's say we're creating a feline that has a constructor, property parent, and we're just saying, well, the mammal should use the same parent and the animal should use the same. So just going backwards up that. And then let's go and do the same canine. All right, now let's give that a good bill and see if anything magically explodes. Boom. Before we've even tried to use this class, we've got a whole bunch of problems. You see, the QObject is ambiguous base of monster. We've talked about the word ambiguous before. Whenever you see the word ambiguous in C++ land, that means C++ is confused over what you're trying to do. So we have created this right here. This is the monster, this is a feline, this is the canine, and it's saying, well, wait a minute. These all have the same base class, and now I'm super confused about which one it actually is. So you, the developer, need to tell me what is it. And it's for this very reason that Qt tends to shy away from multiple inheritance, because you get these weird error messages. Is there a way around this? Yes. But as a general rule of thumb, I'm not going to show you because it's just going to confuse the issue further. The ambiguous base of monster is to separate them and not even really use QObject, although with C++ there are ways around that. But Qt should not allow that. The reason why is because this inheritance stack, when we create something, we want a clear chain here. So rather than using multiple inheritance, you should use what's called an interface, which we're going to cover in a future video, which basically takes this and separates it and says, okay, there's no longer an inheritance chain. You just have these fragments and I'm going to change the colors here just to show that they are completely different. And you can take these interfaces and add them to a class. That way you can add in specific functionality without dealing with the complexities of multiple inheritance. Let's talk about interface. In the last video, we talked about multiple inheritance and how you're going to get ambiguous name and all sorts of other crazy errors, and that there's a better way of doing it. Now, there are many ways of doing this, but I'm going to show you what I believe is the best way, which is interfaces. So what is an interface? Well, it's a contract between objects. Think of that. It's a contract that's saying that you, an object, will include some sort of thing, whatever it is. Let's take a visual representation here. So here we have inheritance. Here's a QObject. We make something, and then we can make other things. By inheriting that thing, we have a clear inheritance chain. The problem comes in when we do multiple inheritance. We use the master class, which was both a cat and a dog, and it got really, really confused. What we're going to do now is break that inheritance chain and instead have interfaces, which is a way of saying, and let me just pick some different colors here. It's a way of saying that the object itself will have these functions baked into them, and this is what we can expect. So we are still inheriting using multiple inheritance, but we're using interfaces instead of inheritance chain. There's a massive debate over whether inheritance R is actually an inheritance chain or not. We're going to demonstrate to do this. We're going to need help of a virtual function. Now, virtual functions are very advanced. We're going to try and overly simplify it. A virtual function is a member function which is declared within a base class and is redefined or overridden in a derived class. What that means is we're going to make a class that does absolutely nothing, and then we're going to inherit that class and then do something with it. That is just freaky. Let's go ahead and take a look. So we've got absolutely nothing in here. We're going to make 3 header files, one to make a toaster, a freezer, and a microwave, and these are going to be classes. So I'm going to say, let's go with right click. I can grab it here. There we go. Add new, and instead of doing class, I'm going to see header file. And let's call this toaster. Notice how it just simply doesn't even prompt us. It doesn't do anything. It just thinks we know what we're doing. It's on us to figure that out. So toaster.h, save it. And then while it's there, notice there's no implementation file. It just says, hey, this file's not even part of the project. Oh, interesting. So what we're going to do here is we're going to actually build a C++ class. This is not going to inherit QObject at all. So I say class. And then we need the bare minimum in here. So I'm going to do the public scope, very important to do this part. If you skip this, you can have a bad time. And we want to use what's called the virtual keyword. Virtual is telling the compiler that we're going to define a function. But we're not really going to define it. We're going to actually just prototype this out. So we're saying, trust us, compiler. We're going to use this somewhere, somehow, but we're not going to actually implement it here. We're not even going to fully define it here. So be real. That's Toaster's grill. And then operating system specific. This 0 should work most of the time. What we're doing here is we're saying equals 0. We're telling the compiler this is virtual and we don't have any implementation at this time. There's none of this. I think Windows with the Microsoft Visual C++ compiler may have to do something a little bit different, but 99% of the world out there can just say 0. Notice how this is not inherited an object. This is a class in itself. This is the basic, probably the most basic interface you could possibly make. What this is saying is we're going to make a different class. We're going to do it later called an appliance, which is going to inherit toaster along with a freezer in a microwave. And then we're going to implement this virtual function. So I'm going to just then add new, and I'm going to do this rather quickly here. Let's add freezer, and then let's go ahead and add in a microwave. Save our C make list. It should automatically detect them and open them up. I'm just going to copy and paste this. Rename the class so the freezer is going to wash in a freezer. Do well, it should freeze. Microwave is going to, of course, microwave things. All right, so getting a little ridiculous here, but actually I don't call it Microsoft because it's going to cook our food. But all of them are, well, interfaces. Now, an interface is a contract between objects. So we don't actually have an object yet. We haven't really even defined it. So what I'm going to do now is I'm going to make an appliance that's going to be able to freeze, microwave, and toast all in one shot. So we're going to inherit all of those, or I should say implement all those interfaces. So I'm going to right-click, add new, and now I'm going to do a C++ class, all this. This is going to have a base class of objects. So we're going to include QObject and the QObject macro, which adds all that goodness in there for us. Now, suddenly, it's very concerned about what we're doing. All right, so appliance.h and appliance.cheap or implementation file, add those in. I'm going to do a little maintenance here and close a bunch of the stuff here. So in our appliance, we need to include our interfaces, include the freezer, Well, if you include the microwave, and let's go ahead and include that toaster. And just for giggles, I'm going to include debug. Now comes the fun bit. We're going to do multiple inheritance. So we've shown this with Monster, how it freaked out and died. And all of that was because of this inheritance chain that we had up here, where it was a QObject and this, and then all of these QObjects, and saying, now, which one of these QObjects did you actually want to initialize in the constructor? And that's what it was really freaking out about. Don't have to worry about that now because we have different classes that don't have an inheritance chain. So let's go ahead and do this. And anybody who is really, really good at watching the video, notice that I omitted public almost intentionally in the last video, although I didn't mention it. And that's what really helped drive that error message on the screen. One of the reasons anyways, toaster and microwave. Now that is a lowercase. I was wondering why it didn't want to do an uppercase there. A sensitivity matters in naming, so got to definitely make sure we have the right sensitivity there. So now that we have these, let's go ahead and put in the public for each one of these. We can do a little magic trick. We can, instead of typing all of it out and implement it, we can just right-click refractor and then insert virtual functions of base class. Notice it's virtual functions, meaning it's smart enough to know it's going to go out here and see, oh, this is virtual. We have created an interface and we want to implement that interface. So I'm going to right-click virtual functions of base classes, and we get this beautiful little dialog here. Notice how it's not just the one we selected. It knows, hey, we're trying to do microwave, toaster, and freezer. This is extremely cool. We already inherit QObjects, so that's not selected, although you could try to do that and it's going to freak out on you. You have some other little options here like add virtual to function or override equivalent. I'm not going to mess with any of that. You can do insert only decorations or insert definitions inside of class or outside of class or implementation file. I'm going to do insert definitions in implementation file. And what that's going to do is actually update this appliance.cpp. Let me move this out of the way. It's going to update that in the background. So it does this ugly monstrosity of a code. You don't need all these public sections here because it's already in public. And now we can just move this up here now. It's already in public before it was in signals. And we can switch over to our code and it's all there. It's already ready to go. Non-void function does not return a value. That's really all it's complaining about at this point, is that we are trying to return something. So, and we cook, we're going to return. And then I'm just going to return true for all of these because this is the appliance 3000 does everything we want it to. This is extremely cool, and I'm going to add some cute debugs in here just for giggles. Actually, AQ info. So this is extremely powerful. What we've done here is we've created a fairly complex object that has, well, 1, 2, 3, 4 things that it's inheriting from, but it has a clear inheritance chain to QObject and the rest are interfaces. So you may be scratching your head going, what is really the difference between an interface and inheritance? I'm going to let you in on a little secret. They're pretty much the same thing. The only real difference here with an interface is that you should have everything as a virtual function. Now, you may find some little gotchas and scenarios and situations where it's slightly different on your operating system. Depending on what you're trying to do, you may have to actually, if you're going to use these via pointers, implement a de-constructor right here in the class. But we're going to keep this super simple for now. Now let's see this in action here. So I'm going to grab my notes and we're going to go in here and go ahead, add in our appliance. And we're going to say appliance. Let's call this I don't even know what to call this machine, 3000. Now, if you ever get something like this where it's saying unknown type of name appliance, even though we know there's an appliance, usually you can go in here and see you've misspelled something or it's not spelled the same way. So I'm going to grab that and grab this. Save it should fix it. So if you horribly misspell something like I tend to do, check the spelling, check the naming. Usually what I end up doing is accidentally doing like a lowercase and then it's going to freak out on me later on. So now we've got our machine 3000 here and I wanted to say QInfo. And then you guessed it, we're going to check this real quick. All right, let's give it a good build, see if anything explodes. And we've got a clean build, and if we run this, it works as expected. Our appliance was constructed. We can cook, we can freeze, we can grill. That is interfaces in a nutshell. So quick overview interfaces is a fancier way of doing multiple inheritance. And I should say it's even the correct way of doing it. And what we're doing is we're doing non-Qt classes with virtual functions. And I remember a virtual function says we're going to have a function, but we're not going to implement it here. We're going to have to implement it somewhere else. And then after we did that, we made a Qt class, I should say class that inherits a Qt object. And we added in the inheritance for freezer, toaster, microwave, right? Clicked refractor and then insert virtual functions of base class, which allows us to add all this stuff in automatically. And from there, we just simply implement the code and it works. Really smooth, really easy. You don't have any that, C++ getting confused about what it's supposed to be doing. Now the class about overriding. What we're going to talk about next is overriding. And it's a little bit complex and a lot of people like to spend a long time talking about this. We're going to overly simplify this because, again, this is of course on programming and we're going to teach you just enough C++ to get by. So overriding, what really is it and why do we need it? Well, we want to change the behavior of a base class. Let me explain here. So we've got a QObject and we are inheriting that from a feline class. We're adding a function called speak. We are now making a lion class, which inherits feline, which means it also inherits QObject, and the lion has another function called speak. How do we know which one of these speaks being called? Because as we've seen in the past, if we create this, a feline and a QObject are also being created. Feline already has that function in there. Oh, a lot of people like to make the super complex. So we have our feline class, which is inherent in QObject as a function called speak. And if we just go in, there is just going to simply print out meow. As terrifying as speaking cats are, we're just going to make this class anyways. Now, lion does not have anything. It just inherits feline, which means it has a speak. But that speak is being called from the feline class. And to really drive that point home, if we mouse over got lion in the air, leet speak, you see it knows it's calling it from feeling it, saying feline, colon, callan, and speak. So in this diagram, it's actually going to call this one right here. We want to switch that down here. It's actually very straightforward. A lot of people like to make this harder than what it needs to be. I'm just going to grab this, go into line but really there we go. We're just going to add it in same name and everything now. It's going to be under the lion speak. I'm going to right click, going to refractor and add definition, and we have a blank slate to work with. I'm literally just going to copy and paste the same code from feline in the line just to save time, and I'm going to make this. Now, if I save and run, you'll see that the lion will roar, in fact, because we're calling it off the lion. So now we flip back to our diagram. We're calling it off this guy down here instead of this one. Very simple, the way that works. And if ever you're confused, you can go into the IDE and just mouse over it, and it's going to tell you exactly where it's pulling it from, lion speak instead of the feline speak. But what if we're in the lion and we want to call the feline speak? And this is where the complex conversation really comes in here, where you're here, but you want to call this function up here. How do you call that? Do you make a new feline? No, you don't need to, because watch, when you run your class feline are already created and exists in memory. It's already constructed. We just need a way of accessing this. And this is called the base class because we're inheriting from it. And it's very simple, very straightforward. You're going to say feline. And then the name of the function is, remember, feeling already exists. It's right here. We're inheriting it. So we're just going to call feline and then call the function. So this is what's called calling a function from a base class. And now we should see roar. And so it is calling it from feline. Again, this may seem overly complex, but once you really wrap your head around it, it's pretty straightforward. You just need to know what scope you're calling it from. Are you calling the feline speak or the lion speak? Because we're in the lion class, we're calling speak directly. We want to call it from a different class. We need to use that class's name. Let's talk more about QObject. One thing that often mystifies newcomers as well, QObject itself, it's the base class for, well, pretty much every Qt class. I say pretty much because when we get into more advanced topics like generics and templating and things like that, QObject, as you've seen, does not like to be copied, so it doesn't play well. Therefore, it's not all its moss. But let's take a deeper look at QObject here. So I'm just going to, let's right click here, add new. We've done this before. You're not seeing anything brand new, but I just wanted to slow this way down here. So base class, we've kind of taken this list for granted. Custom, yes, you can do whatever you want, but we've been saying QObject, and notice it's smart enough to say include QObject and add the QObject macro. But what are all these other things that we've been ignoring? So first off, widgets and main window, those are part of, well, the Qt widgets, which is displaying desktop style applications. You're actually looking at one right now. This dialog, this defined class window, and Qt Creator itself are written and Qt with Qt widgets. Then you have Qt declarative item. What this is way advanced. We're not even going to really touch on this. Don't even pay attention in Qt quick item. This goes into QML. We talked about the very beginning of this whole thing, how once you leave Qt core and you go into the graphical layer, you can either go with widgets, what you see now, or QML, which is rendered pretty much everywhere from TV, smartphones, desktops, you name it. It's their newer graphics. That's why we're pretty much just staying with QObject. Now, you also have to understand that if you include these things, you also need to include the graphical layer, which we don't want to do. And then, no, I don't want to copy that. We're going to go in here and we're going to say test that H and S, that CPP. There's some other things going on here as well. You'll notice right off the bat, find packages is looking for components core. So this is just the core library as you get more and more advanced, especially if you go into my intermediate or advanced course. We're going to be working with things like concurrency, threading, networking, you name it, we're going to do it. But we're micro-focused on core. So what really does core bring to the table? Well, other than just some of the things we've been talking about, the biggest of them all is QObject. Now, we've touched on QObject being the base class, but why is it the base class? What are we really talking about? And then this macro here that we've kind of just said, well, it's a macro and you need it. And honestly, if you look that up on Google, most of the responses you're going to find are people going to say, well, you just simply need it, but they don't really explain why. A real hint here is at the very bottom where it says Qt's meta object system. We talked about the compilation process and how Qt kind of changes that a little bit. And at the very last minute, it comes in and it does what's called mock or meta object compilation. What's happening in the background is as your program is being compiled, it's looking through all these classes and going, oh, this is a Qt object and it's got this macro. So I need to create meta information. We're going to go out to the documentation and you can either Google this, you can literally take a QObject and Google it. If you do that, spoiler alert, make sure you're on the right version. There are some minor version changes between previous versions of Qt and the more modern version. But this is huge. I mean, their documentation is, well, world-class. You can see I'm just going to grow very, very quickly. It's massive. That is how much functionality is inside of QObject. And you can see how to get this. You need to add the core or CMake, do the find packages in the target link if you're ever confused. CMake is the build that we're going to be using to make QMake, is what we've used in previous lectures and previous courses, because that is Qt's proprietary build system. Obviously, their proprietary build system is much cleaner because it is defined specifically for Qt. That inherited by we understand the concepts of inheritance. What we're talking about here is, well, these are all the classes that use QObject. And you can see there's just a lot of them in my browser, just kind of stops trying to figure it out. There we go. Then you can list all the members. We're not going to really do that now, but you see all these connections and things like this, connect, disconnect. What are we talking about here is signals and slots. This is one of the mainstays of QObject. This is why you want QObject, so you can communicate in virtually real time between two objects. So you can take two different classes, for example, car and dog, and make the dog chase the car. Or if the car honks the horn, the dog runs away, those kind of things. Very simply, we're going to cover those kind of things in later videos. Now, the public functions. Remember, whenever you see the keyword public here, that means it's available to everybody. Everybody can use these. You've got your constructor, which is your parent. Right here is a null pointer. This gets into how Qt handles memory management. We're going to talk about that in future videos and our deconstructor. But then we have things like block signals, children. When you see children, you're thinking of an object tree. So yes, your object that you created, because it's a Qt object, can have children in it. So you can make like a classroom and have students inside of that. And then in memory, when you destroy the classroom, all the students are destroyed. That's really more of it now that I say it out loud. But I thought it was a good example in my head. Point being, there's a lot that gets added. And just by inheriting QObject, and this is arguably the pinnacle of using Qt, you need this if you want to do anything Qt related. It's even got help for threading built right into it. So pretty much anything you can think of, you want to use QObject. And you get this handy little delete later, so if you want to use memory management. And you don't want to delete the object now, you could actually signal garbage collection in the background where Qt is going to track that and try to delete it later. And then signals and slots, we haven't really touched on those home, but basically you can create a signal and throw it out there and say, hey, something's happening. And then one or many other objects can use that in what's called a slot. Think of it like plugging into an outlet. You are now connected to it and you get real-time information. But let's reverse real quick and go back to our humble little class so we gain a lot of functionality just by being part of the QObject. And if you're ever in the IDE and you question something, just highlight it and press everyone on the keyboard and it brings up the help system. You can have one again and it takes you to the full-blown help system, which is literally the document we were just viewing. So don't think you got to crack open a web browser every 5 seconds. It's literally baked right into the IDE. Also, this macro, we haven't really talked about this. Let's dive in. So if we go in here and we just scroll and find, it's baked right in. If we click it, it's going to say the Q_object macro must appear in the private section of a class. What does that mean, private? It means it's not available to the outside world. So for example, if I go in here and we're really getting into scope, but if I say sh, and let's say test TE that you can't say Q_macro, it's just simply not going to let us do it. So these are the publicly available things. And you can see how you have signals whenever you have that little bar with a little, I don't know, like Wi-Fi signal coming out, that's a signal. And then you can have slots, and let me see if I can find one in here. Yeah. This little indentation, it looks like an outlet almost from the top down, that's a slot. So a signal would admit something in a slot would consume that. All of that happens because of this humble little macro right here, which is in the private section. It's not available to the outside world. And if we really dive into this, really what it's going to tell us is it's where services provided by Qt's meta object system doesn't really tell us a whole lot about what's going on. I almost dare them to be less descriptive. But if you look up the meta object system, they have a whole document on this, and it gets very deep, very fast, way more than what you probably ever want to know. But it says the key to _object macro inside of a private section of the class declaration is used to enable the meta object features such as dynamic property signals and slots. So you need this if you want to do any sort of communication, and the meta object compiler or mock supplies each QObject subclass with the necessary code. Let's see that. So here's the folder I have my code in. We're going to build, and you'll see another folder pop up here. So I'm just going to give that a good build, assuming I don't have any little error. All right, so we've got to build. We go back out here now. Here's our build folder, and we've talked about this in a little bit. So here is our binary on Windows. You can see it. And then we have this autogen. Let's go in here and look. See, here's our mock code right here. If we crack this open, doesn't really seem super helpful, but you can see how we've got this test CPP. So we're including this file here, I should say, this directory, this file. So this is an auto-generated thing. Pretty cool, actually. All of that is in here. And then there's this guy. And here's the code that it generated. And this is what Mark created for us. And this is basically saying take our class name test and then do any connections for signals and slots and things of that nature in the background here. Also, it provides a lot more information, so you have to remember. A lot of Qt was built before a lot of technology that exists today was even thought of. Qt was just that ahead of the curve. And Qt does things like their own meta information of their own typing system. So, for example, you can get runtime type information support through the C++ compiler. This also goes through the inheritance tree and the Q property system. A lot of this is way more advanced than what we're going to talk about in this course because you do get into high-end things. But basically, you can have a property system that uses signals and slots. So, for example, you could say change somebody's age from 21 to 22. And all of these events fire off automatically in the background. It gets extremely powerful once you really master this, but it all starts with the humble QObject macro. All right, so that, in a nutshell, is the foundational cornerstone of this. And yes, we are simply just hitting the tip of the iceberg on this. It's way more than we could cover in one single video. And the meta object system itself is extremely complex. But under the hood, we don't have to even think about it. It just happens if you're really curious. There's also this extra information. I always go down to the C also, and it just, how far down the rabbit hole do you want to go? You can read about signals and slots and talk about how objects interconnect, which we're going to touch on. You can look at the Qt meta object itself. And whenever you hear the term meta, think data or additional data. In this case, it's data about data. We're literally defining what things are and how they work. Now, a lot of this, especially if you're new to C++, it's just going to look like complete gibberish. But at its heart, when we talk about mock, we're talking about the meta object system and unQt. It's responsible for signals and slots in inner object communication mechanism, along with runtime type information and the Qt properties system. All of that makes Qt stand out from pretty much anything else out there. Yes, there are some other libraries and frameworks that do similar things, just not as well as Qt does them. All you really need to focus on from a beginner's perspective is include Q, object in Q, inherit object, make sure you have this macro, and then add signals in slots as needed. You may have noticed we have this signal section here, but we don't have a slots. We can do something like this. And then start adding our slots in there, and you can make public slots and private slots. We're going to talk about all that later, but I wanted to really touch on that just in case there's any confusion. To summarize what we learned, let's make an application. This video, we're going to practice what we've learned so far, and we're going to make an age calculator, but want to wrap it in a class, and we're going to do some encapsulation, something we really haven't touched on a whole lot. I may go really fast in some spots and really slow and others just to kind of highlight what I'm doing. So we're going to make a class. We call this age calc. Now, one of the things you're going to ask is, does this really need to be a QObject to this point? No, it really doesn't, but I'm going to do it just because I want to. It really doesn't add a whole lot of overhead to make something a QObject. That's age count, each and each count CPP, add those into a project, save, and then it will configure and scan. And then, of course, we have our beautiful header and implementation file here. So I'm going to flip over to the header here, and there's some things I want to do right off the bat. I'm going to add a private section. We haven't really talked about the private section a whole lot. You can either define it manually or you can do it up here, because up here is, well, private. If you haven't defined what it is, it's just private by default. So up here is private. I personally tend to put the private stuff at the very bottom. It doesn't really matter which way you do it, just whatever works for you, to be honest. And this is where we get into coding standards and conventions and things like that. So I'm going to say into m_age. And you may be asking why underscore. We're saying this is a member variable or is a member of this class. So a typical naming convention that I use is _use. Whatever works for you doesn't have to be named anything. Well, you actually have to give it a name, but you know what I mean. You don't have to follow some specific standard. Say QString and then again mname once again. Use what works for you. Now, a lot of times you're going to hear people say, well, we need to encapsulate things into getters and setters. and you're often scratching your head trying to figure out what they're talking about. Look at this very simple class so far. Private, our variables are in the private sector, so they're not available to the outside world. Let's go and test that. I'm going to go on in main and I'm going to include QDebug. I don't really mean it's already included by QCore application, but just in case something changes in the future, and I'm going to make the age count. And we'll call this calc. Now, if I say that we get all the QObject stuff, remember, we did _, nothing's appearing. Notice how it's just saying there's no member what? All right, so I'm going to actually copy this. Here, I know that's, and so I'm going to just initialize that. Notice now it says, is a private member. We're trying to access that from the outside world. If it's declared private, it can only be modified from inside the class, not from the outside world. Only public can be modified from the outside world. So we want to do something called encapsulation. So I'm going to right click on this variable, refractor, and we're going to create getter and setter member functions. That looks extremely scary, but all we're doing is we're allowing the outside world to set and get that variable in a member function. A member function is just a function inside of a class, basically, and it adds the int_age function and void set age. This is the standard naming convention that Qt uses. This really is not abundantly important. You can name these however you want, but if you want to use some level of Qt property system or even automation in the future, stay with their standard naming convention. Going to do the same thing for name, just right click refractor, getter and setter, and it does the same thing. We can switch over to the source here, and on the implementation, you can see it does this. So why do you want to do this? What's the point of this? Well, this is called encapsulation. So, for example, if I did not want them to be able to set the age, only read it, I could get rid of this set age and also in the header file, and then they could only read it. But we still have a variable that we can use. Also, this is private, this m_age. It is a private member variable. I don't want the outside world modifying it directly. I want them to use this function. We get a value or a copy, and we can do what we want. We can validate it, check it, sanity, test it, make sure that it's above 0. Anything that we really want to do. So by default, I'm just going to leave these blank, but you could put any sort of logic. I'm going to put logic here. So if you wanted to make sure it was greater than 0 or less than 100, you know, for example, like age greater than 0 or something like that, this is where you would do it. All right, now that we've got that squared away, let's jump back here and we're going to make a couple extra little functions here. I'm a Sergeant Dog Years. And let's grab these, and in case you're wondering why I'm using the keyword, you really don't. It just says that it is now a constant function. Again, there's more technical explanations of that, but from a very high level beginner perspective. Just take a huge leap of faith here. I hate saying that because I like to explain every little thing, but we'll have a long conversation. All right, so we're going to right click dog years, good refractor, and then add definition. And then cat years. Now we're going to add definition. And then human years now, once in a while you'll get this and it won't pop up like it is there now, but it will just say rename symbol, it occurs, and it won't have this stuff. That just means that it hasn't really caught up with what you're doing, and you can definitely feel free to type this in manually. However, using the ID is vastly faster. So dog years, I think dog years is by 7. Term age. Now, you may be wondering if you need this keyword. If you need to do something like this, you'll actually see people do this. And I've done this myself. You do not, because by default, it's already going to be in the current object, which is what this represents. So I'm just going to make some numbers up. I think that cat years is by 9. And then human years, really, we could just return MH without any modification whatsoever. I don't even really need that. But just for the sake of completeness, we can go dog years or human years. Now, in case you're wondering, like if you highlight continua F1, you're going to get absolutely nothing from Qt because it's not part of Qt. I wanted to highlight that. That's part of C++. So if I do int, well, see, now it's trying to find it, but it can't because it's just simply not part of Qt. Or if I do QString, it should open the file right up. That's how you tell if it's something part of standard C++ or if it's part of Qt itself. Now that we've got our beautiful little class here, we can test this thing out. I'm going to go in here. And I want to make a couple different ages or a couple of different age calculators. I'm going to say, Brian. I can't even spell my own name kind of day. I've had you ever have one of those days where your brain and your fingers just are not working? So I've got two of them here, and I'm going to say, Brian, that, and one set age, 46. And Tammy, at age, let's say Tammy is 27. Now, I want to print this out. I want to print out the human years, the dog years, and the cat years. And I could do that right here, but it would be easier if I just do it in a function that way. I have code reuse, some say void. And then let's go page count. We have some decisions here. We have to, and that object, because it's a Qt object in a manner in which it's not going to be copied, so we can either work with a pointer or we can pass it by reference. I'm going to do by reference. Actually, let's just call that calc. And then I must say QInfo. And we haven't done the name yet down here. We should probably do that. We're going to do set name. And then let's go and do the Tammy. There we go. Now, you may be curious, what is the difference between the set name and if we go into, let's say, Tammy and we do a set object name? Well, that's baked right into QObject, where our name is baked into our age calc class. Which one should use? Well, personal taste depends on what you want to do and how you want to do it. Personally, I don't use the set object name unless I really want to make myself write into Qt. All right, so we're going to get the name, and we're going to say human years. And let's just return that out. And we can just very easily, through copy and paste, you dog years. So the major takeaways here is we can very quickly and very easily make a Qt object. We can add getters and setters using the IDE very, very rapidly. We talked briefly about public versus private and how public is available to the outside world. Private is not. And you may want to encapsulate things based off of whatever logic you want. Typically, you want to use encapsulation, i.e. getters and setters, because you don't want the outside world to modify this directly without you being aware. Then when we go in here, we want to be able to use these objects in other functions, and we have to avoid copying it. So in this case, we're going to do a by reference run. And let's see this in action. And would probably help if, yes, I actually use the function. How embarrassing. All right, there we go. Minor problem. All right. So now I'm going to actually use Brian, and then let's use Tammy. That's what I mean by it doesn't matter how many years of experience you have, you will always screw something up. There we go. Now it actually works. So Brian would be, wow, a very old dog or an ancient cat. And Tammy would be a much younger person. Dog and a cat works as expected. Great guys watching these long video about uses of class in Qt6. I hope you liked the video. For more, please like, share, and subscribe the channel. Next video, we will talk about signal and slot implementation in Qt6.